The second learning objective in 3.1 is to deduce the position of elements in the periodic table. So we have to determine the group, block, and period of an element. So how we're gonna do that is by doing these 4 steps. So first, you need to write the electronic configuration referring to Hans rule, Pauli exclusion principle, and Aufbau principle, which you already learned back in chapter 2. Next, you need to determine the block, which is the last orbital in the electronic configuration. Okay, so we're gonna have 4 blocks S, P, D, F. Step 3 is to determine the valence electron. Okay, please don't get confused between valence electron and outer electron. Okay, so the last step, step 4, is to determine the group. For S and D block, the group number is equal to the number of valence electron. But for P block, okay, P block is quite special. The group number is equal to the number of valence electron plus 10. Okay, since P block is the block for transition element. Now we're going to determine the block, period, and group for potassium, chlorine, and nickel in example 1. For the electron configuration of potassium with proton numbers of 19, that would be 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. For the condensed configuration, you can condense all the inner electron, which is this one, 1s2 until 3p6, and condense it as an element in group 18. Okay. So for this one, we have 6 plus 2 plus 6 plus 2 plus 2, that would be argon. So this whole inner electron can be condensed as argon, since argon has 18 proton number. Okay, so that would be, okay, so condensed configuration can be written off as bracket your elements in group 18, close the bracket, and write your valence electron. Okay, so for potassium, the inner electron can be compressed as argon. So hence bracket Ar and write the valence electron, which is 4s1. So number of inner electron we have calculated before, that would be 18, and the number of outer electron, okay, and the number of valence electron, you should refer it to 4s1. So the number of outer electron is 1 electron, and the number of valence electron is 1 electron as well. Again, to determine the block period, and group, you need to refer to the valence electron as well. Okay, so refer to your last orbital in the electron configuration, okay, which is for S1. So the block for potassium would be block S. The period, for the period, so look for the highest number of N, which is 4. So it must be period 4, and the group. Okay, so the valence electron is 1, hence it must be, so potassium must be in group 1. Example 2, chlorine with a proton number of 17. So the full electron configuration is 1s2, 2s2, 2p6, 3s2, 3p5. Yep. So you can condense all this inner electron, which has a total proton number of 10 electrons. So which element in group 18 has 10 electrons? Yes, that would be neon. Neon has 10 proton number. Okay, so the condensed configuration, bracket, neon, and then write down the valence electron, which is 3s2, 3p5. The number of inner electron is 10. Number of outer electron, that would be 2 plus 5, 7. And the number of valence electron would be 7 as well. To determine the block, period, and group, you have to determine the valence electron first. Okay, which is, for chlorine, it would be 3s2, 3p5. Okay. So chlorine would have block P, period 3, and group 2 plus 5 plus 10. Okay, remember for P block you need to plus 10 to determine the group. Okay, so the group for chlorine would be 17. Nickel with a proton number of 28. So the full electron configuration must be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d8. Okay, so you're gonna condense 1s2, 2s2, 2p6, 3s2, and 3p6. Okay, so that would be argon. Okay, so again, this is the same as potassium. 18 plus 8, which is equal to 26 electrons. And for the outer electron, there would be 2, because we're gonna look at the orbital of highest N. And for the number of valence electron, so for s2 3d8 is the valence orbital. So 8 plus 2, which equal to 10 electron. Again, to identify the block, period, and group, refer to your valence orbital, which is 4s2 3d8. So for the block, okay, refer to the last orbital, that would be block D. Okay, and the period, refer to the highest end. So nickel would have a period of 4. And the group, you just sum up the number of protons in valence orbital, which is 8 plus 2 equals to 10. So nickel is in group 10. Example 2. Classify the following elements into their group, period, and block. Alright, so first of all, I want you to highlight the valence orbitals. For P, that would be 3s2 3p6. For Q, that would be 4p5. Okay, but remember we have 4s2 as well. Okay, so these two is the highest end, so there are the valence orbitals. So for R, that would be 4s2. For S, that would be, okay, look at, we have d orbital. Okay, so what did I told you about the orbital? You need to consider the last two orbitals as your valence orbitals. Okay, so highlight the 4s2 and 3d3 together. For T, okay, again we have 4p6. Okay, so which means that we have 4s2 orbital as well as our valence orbital, so highlight that as well. Okay, so I already list down all the valence orbital, so let's find out what are the blocks, periods, and groups. Okay, for P, for P it would have P block. For Q, let's finish off P first. So the period would be, the highest end would be 3. Period is 3. And the group would be 6 plus 2 plus 10. Okay, because we are dealing with P orbital. So the group for P is group 18. So P must be a noble gas. Oops. For Q, it has P block, period 4, and again 2 plus 5 plus 10, so the group is 17. For R, the block is S, the period is 4, and the group is group 2. For S, okay, so be careful because S is in block D. Okay, but for period, look at the highest end. Okay, so that would be 4, and the group would be 2 plus 3 equals to 5. For T, the block would be block P, period of 4 and group of 6 plus 2 equals to. Is this right, class? Is it only 6 plus 2 or 6 plus 2 plus 10? Yes. Okay. You must add 10 to find out the group because T is in P block. Okay, so that would be the group 18.